Okay, this video is dedicated to working on percent problems. So the first thing we have to realize, the objective here is percent can be done in 3 different ways, and we want to be able to solve for the part, or the total, or the percent. Okay, so those are the main elements here. So let's take a look here at the percent. Percent can be written 3 different ways. Percent means the ratio that compares to out of 100. So out of 100 people, if I said 20% of people, you'd say out of 100 people, 20 people. So when we look at 40%, the way to write it as a fraction is 40 over 100. Okay. Now again, we always want to reduce that, and 20 goes into both of those 2 over 5 times. So that would be the reduced fraction, but we're talking about how many pieces out of 100. As a decimal, it's out of 1. So we're talking about 0.40. So we got to move the decimal place. Okay, so I'm just going to put a little, we got to move the decimal to make that work. So it's 0.40. Over here, notice if they give us, like, as a fraction, 37 out of 100 as a fraction, that's the same thing as 37% or 0.37. Okay. Over here, they give us a decimal. So how does that look as a fraction? 63 out of 100 or 63%. Okay. So decimals and percentages and fractions are all related in this fashion. Now, the other key thing to notice is, what is 100%? That's 100 divided by 100. 100 out of 100 people. So if you reduce that, what's that equal to? 1. Okay. So if you look at it, it's like 1.00. So that's total 100%. Okay. So everything's out of 1. So if I say 100% of something, that means the whole item. So if I have 100% of a sandwich, that means I have one whole sandwich. So that's what we're looking at in these cases here. Okay, so let's go ahead and write these into as a decimal and a fraction. Okay, so as a decimal, it's going to be 0.60. Okay. As a fraction, it's going to be 60 over 100, okay? And 20 goes into both of those, okay? So 20 goes into 60 3 times, and 20 goes into 100 5 times, okay? 80%, so that's going to be 0.80, and it's going to be 80 over 100, and that's going to reduce down to 4/5, okay? Again, dividing both top and bottom by 20. Now notice this one, 450%. So that means like your paycheck went up 450% over the last 10 years. So that would be, as a, let's start as a fraction this time, 450 over 100, okay? Now notice if you type that into the calculator, and we'll do it over here, 450 divided by 100, we get 4.5. So that's what it's going to look like as a decimal. So it's 4.50. And notice it's bigger than 1. So it's bigger than 1.0, which means it's more than 100%. Okay. So 450% is really 4.5, 4.5. Okay, now solving percentage problems, a lot of times I notice students, they say they can get the percentage part. They're like, oh, I just take this and divide by this. And that's for one type of problem. We want to come up with an equation that works for all type of percentage problems, because you're going to either find a percent, find a total, or find a part. Okay, so if I say I ate half the pie, the half is the part, the percent is 0.5, 50%, and the total is one whole pie. So you have 3 pieces. Okay, so let's take a look at this one here. Percent of 40, that's the total, is x, and that's the part. So I'm going to have 0.25. You always want to show it as a decimal. Okay, so I'm going to make a little note here. Show it as a decimal. Okay, 0.25, and then times 40, that's the total, is equal to the part. And I'm going to put x as a thing there. So 0.25 times 40, in my calculator, it's going to get 10. Okay. So notice the part is typically, I wouldn't say always, but typically smaller than the total. Okay, let's take a look over here. What percent? So percent goes first. So x, what percent of the total is 80 is 15. Okay, and these are where a lot of students get used to. They're like, oh, to get x by itself, all we do is divide by 80, both sides, and x is equal to, and again we do it in the calculator over here, 15 divided by 80, and get, okay, now look at this. Here's my decimal. So I have to change that to a percent because what it's asking for is what percent. So I'm going to move the decimal over 1229. So it's going to be 18.75%. And you always want to put the symbol there. Okay. So that's the percentage. Okay. If you think about it, 15 is a part of 80. And how much? 18%. Find 150% of 200. So the first thing you have to know is notice it's 115%. That's bigger than 1. So we're going to have more than 200. So I'm going to do percentage. So 115. But remember, we have to do it as a decimal. So I'm going to move the decimal over 2 times 200 is equal to what? Okay, so we're finding 115% of the total is equal to the part. Percent, total, part. Those are 3 pieces. So again, let me just kind of highlight all the pieces in all these equations. If you do it this way every single time, you're never going to mess it up. Okay, so simply we just multiply this together. So we're going to do 1.15 times 200, and we get 230. So back to over here, 230. And notice 230 is bigger than 200 because we want up 15%. Okay, 45 is 40% of what number? So that's the total. So 40% is going to go up front. The total right now is here. So percent total is what? Okay, and then that's the part, 45. So obviously the x is going to be bigger than 45 because 45 is only a part of it. So to get x by itself, we're going to divide by 40, both sides. 0.40 I should say. And x is equal to what? So we're going to go over here on the calculator. Very important to use the calculator for all these problems. Don't worry about doing these in your head. Got a lot of decimals and fractions going on. 112.5. Okay, so let's write that one down. 112.5. Okay, you could always check your answer. You could type in 45, go backwards, divided by 112.5, and we're going to get 0.4, which is 40%. So it's a good way to check your answers as well. But notice I do the same setup every single time. Okay, percent total part, percent total part, percent total part. Okay, so that is the key setup for all of these. The same thing can be shown for here. Okay, find the percent of the situation. Okay, so now we have to take it out of the context. So again, I'm going to do percent total equals part. Okay, $4 tip for a 22.30 bill. So the percent of the total 22.30 is equal to $4 tip. Okay, so what I'm solving here is percent. So that's going to be my variable x. So to get x, we simply just divide both sides by 22.30. Okay. And a lot of you are probably saying, well, I can just do this in my head. Why do I have to set the equation? As problems get tougher, you have to be able to rely on equations. So that's why I set them up the same every single time. And I just use my calculator to divide it out. So notice we're going to get 17.9%. Okay, so 17.9%. And notice I'm rounding it. I'm moving the decimal. I see a 0.17, but I'm going to write 17.9. I got to move the decimal 2 places over. Okay, what percent of the total bill of $39 is equal to $3.12? So again, divided by 39, both sides, and x is equal to 3.12 divided by 39. So we're going to have 8% tax. Okay, so notice again, I see that 0.08, move it 2 decimal places, and 8%. Okay. Percent of a total of 92 people, so I'm just reading from right here, is 14. So 8% of total equals 14. So again, divided by 92, and x is equal to, use my calculator, and we're going to get 15.2%. Again, I'm always rounding. I'm looking at moving the decimal 2 times and then that next digit, and then looking behind it to see if I have to round it up or not. So again, we're looking at all the pieces over here. Percent total equals part. Okay. Now we also have word problems. We have the same type of context. So what we're going to take a look here is Kyle bought a shirt that was originally $39.99. The shirt was marked on sale for 25% off. So we're taking away. So we're subtracting. Okay, because we're marking it off. So I'm going to make a little note here. Subtract. How much did Kyle pay for the shirt? So again, we're going to use percent total equals part. So we're going to do, okay, 25% of the total of $39.99 is equal to what part? Okay, and I'm just going to call that x. So again, I just type my calculator, 0.25 times $39.99, and I'm going to round that up, so we'll take off $10. Okay, because notice I rounded up because it's $9.99, but that's 75. That's bigger than 5. So we're going to take $10 off. Okay, so that's how much we save. So we got to take the $39.99 and we got to subtract the 10% or the $10 we saved. So really, the answer to the question, how much did he pay for the shirt? Well, that's how much did he pay? Well, it's $29.99. So he saved $10 and paid $29.99. So you got to make sure you answer the question. So we found how much he saved on that problem. Okay, next one here. The school newspaper reported a 32% of the students' body is in athletics. If the student body consists of 2,000, how many students are athletics? So we have to identify what's the pieces. 2,000 is the total. There's your percent, and we're finding the part that are in athletics. So again, percent total equals part. So let's just plug them in. 32%, right, as a decimal, so 0.32 of the total of 2,000 students is equal to what part? Okay, so 0.32 times 2,000. And again, I like this because I set it into the equation and it just tells me what to type into the calculator. So that's the nice thing about algebra. It does a lot of the thinking for you, and we get an answer of 640 students are in athletics. Okay, and that answers that question right there. Okay, last example right here for word problems. Linda bought a coat on sale for $29.40. So I'm guessing that's the total. The sale price was advertised as, oh, actually not, 6% off the original price. So the original price is the total, and the sale price is the partial. So you're only paying for a portion of the total. So that's the new part, that's the original total, and it's 6% off. Okay. So what I like to do is I'm going to do this problem a different way. I'm going to say, okay, if we saved 60%, how much did we pay for the jacket? We paid 40% of the original price. Because remember, 100% is total. So if we save 60%, then that means we paid for 40%. So I'm going to set it up backwards. Because that way, up here, notice we had to do subtraction. I don't want to do that down here. So I'm going to say 40% of the original price, don't know what it is equal to the new sale price of $29.40. So there's my setup. 40% of the original price is equal to the sales price. So now, to get x, just divide by 0.4, both sides, and x is equal to, and use your calculator, $29.40 divided by 0.4. And the original price was $73.50. So let's go ahead and fill that in. $73.50. So that was the original price of the jacket. Okay. And that's, I like this example because we kind of simplified it by not saying how much did we save. We're given how much we paid for it. So that's a good way to look at what does 100% mean. 60 and 40 there. Okay, the last example here is showing percent markup and down. So a lot like the last examples, but here's a great equation. So to find a percentage change, the best thing to do is put new minus old, whatever the new price is minus the old price, and it's always divided by the old price. I shorten it and I always think of no divided by O. And that's a great way to set it up. So let's take a look at some examples to understand how this setup works. Dell's new computers is priced at $1,100. Okay, so that's the new price. Notice I'm marking the text, so that's a great thing to do in these word problems. Mark the text, identify what the pieces are. Best Buy is selling it for $984.50. What is the percent change in the price of the computers? Okay, Um, so this one is a decrease, okay? Because notice, actually, this is the old price, so that's what they sold it for, okay? Best Buy is selling it for this, so that's the new price because we're going to buy it on sale. So the new price is $984.50. That's the new, minus the old price of $1,100 divided by the old original price of $1,100. So now we just plug it into a calculator. So what I'm going to do first, $984.50 minus $1,100. Whoops, gotta get another one in there. 1,100, and that is. Now notice the negative sign showed up because that means it's discounted. So the price went down. So that's important. The setup's good because it tells you if it's positive or negative. So now we divide it by $1,100, the original price, and let's see what the percentage comes out at. Notice negative 10.5% because I got to move the decimal. So we're going to say negative 10.5%. Okay, so that is how much it went down. It was originally $1,100, went down to $9.84. Okay, last example right here. The cost of a video game is on sale from $59 to $45. So that's the new price. It's the new markdown price is $45. The original old price is $59. So again, new minus old divided by old. So we're going to type it in. 45 minus 59 divided by 59. Okay, so let's see what that equals. 45 minus 59 is equal to 14 negative. And again, it tells me negative, meaning that it was a discount, so it decreased. And let's divide that by 59, see what happens. And negative 23.7%. Okay, so great example there. Okay, so again, I want you to try these examples right here. Just 4 examples as a review from the video that we just saw.